Good morning. Good morning, everyone. My name is CH Tan from CADVision. So today's webinar is about think differently, multi-body techniques. So this is our agendas today. So we'll discuss a little bit about what is the difference between features and bodies in SolidWorks. Okay, in comparison into our real life. So next thing is we're going to look some of the case study when we apply multi-body techniques, which can save our times. Okay, for example, when we're doing pattern, we're doing some Boolean operations. Then we will also look at some case study. Okay, also using multi-body techniques where you can have to save the day. Okay, and also if we have times, we'll talk a little bit about parts to assemblies and assemblies to parts. Okay, so what is the difference between features and bodies? We can always imagine that features actually is a set of instructions. Okay, for example, actually every time we create an extrude or extrude cut, actually we are telling SolidWorks that we need to do this extrude. So extrude is a set of instructions, is like a user manual telling SolidWorks how to do the jobs. But the body is we can imagine the body is a physical geometry where we can touch, okay, we can move, everything's okay. They are the result of the instructions, meaning that from the instruction that we're given, this is a result of the instructions. So we have the bodies. Okay, so I will show actually today I'm going to show you a little bit more in a real case study rather than in a theory wise. Okay, so first thing is last minute design changes. Okay, like for example, if let's say we are actually having this part at the very beginning, our design is like this, but at the very last minute we found that our design should be like this. Okay, so when we want to change from this design to this design, there are many ways to do. Okay, if let's say you do not familiar with multi-body techniques, most probably you will redo this part and you add this part and this part. If let's say you are familiar with multi-body techniques, okay, you will do it different way. Actually, just very easy. You just imagine if let's say you ask a kids, okay, to do, how will the kids react? Actually very simple. The kids will chop this part off, take a knife, chop this part, and then it will turn it and glue it back, then you get this shape. Okay, and of course we will perform some patternings, copy, so we make it 3. Okay, so actually every time we just need to think what if the kids do. Okay, I'll show you in SolidWorks how we actually do this part. Okay, this is the one. So for example, we are already in this stage, but we want to achieve this result. Okay, first thing we can do is, like just now I said, like kids will do, we'll chop this part off. Okay, so I will create one plane. Okay, for example, I will create a plane based on my right plane at this point. Okay, then I use the functions. We call it split, and I cut the part. So I want to keep both bodies. Okay, right now you can see that I have a folder here saying that I have 2 bodies. Okay, previously before splitting there's only 1 body. Okay, right now I have 2 bodies. So what can I do with these 2 bodies? Okay, first thing is I can turn it, I can move it, and I can do many things. Okay, for example, I will use the function we call move copy. This is the function that we are always use when dealing with multi-body techniques. Okay, so okay, I thought a little bit of this one. From here we can we have the option either we want to move or we want to copy. Okay, and we want to translate or we want to do some rotations. Also, we have the option of constraints. You click on this button, we will come to the constraint page, where the constraint page is actually exactly the same as doing assembly matting, like a coincident, parallel, perpendicular, so on and so forth. So if I want to go back to the transect rotate, I just click here. Okay, so what I want to do right now is a constraint. Okay, for example, body to move. I want to move this part. Okay, so what I can do is, okay, I select this face and this face. Then these two faces are going to align. Okay, of course I can flip the elements. Okay, it's here. Okay, then just add. Next thing will be this one. Right, let me choose this one and this one. Of course, similar to assembly, I can add some distance. Let's say I put it 10. Okay, and just to make sure, okay, it is 9 into place. I add one here and here. Okay, let me check this one. Here and here, then okay. Okay, I already turned this part on. Turn this part the sides. And lastly, I just need to join this one to this one. Okay, but not now. Right. So right now, you see, my final result need to be like this. Okay. So I have this one. I need to copy 2 more. Right. So similarly, I can use back the same functions. Move, copy. Okay. This times I will use translate, rotate. You see the copy over here. I just click this one and make a copy. Okay, so I can drag this one go out. Okay, because I don't want to after copy is exactly the same locations. So I need to add an intermediate step where I put one instance over here. Then let me click OK. Okay. Then again I repeat the same techniques. Move, copy. This time I use constraint. Okay, body to move. This one and this one and this one. Okay, it's like playing assembly. Flip it. Okay, just to make sure this one and this one. Then okay. See? See, I already have this one done. So how about the opposite side? Make another move and copy? Yes, you can do it, but I will prefer, I will do it a mirror. Okay, so if let's say I were to copy a cut or maybe an extrude, I always use the features to mirror. But this time, this is the whole bodies that I want to mirror to the opposite side. Then I will view body to mirrors. So let me click this one and just okay. I have this thing. Okay, the problem is now this thing is separated. It is not joined because I have 4 bodies here. So right now I want to combine it. I want to glue it back like a kid. I want to glue it back into one single body. Okay. There are many ways to do it. One of the easiest way is using a bridge. Okay, I just simply make a sketch on this plane, copy the sketch, and I make an extrude. Okay, just up to surface, this one. Okay, so you see everything will become one. Okay, one thing you want to notice is we always have the option whether you want to merge result or we don't want to merge the result. If let's say I keep this one unchecked, then I will have 5 separate body, okay, including this one, the newly created one. So I can straight away click on merge result, all bodies. Okay, then I get this one done. Okay, rather than I redo everything, I just add few more features here, which is I chop it off and I turn it, position it, orientation, then I glue it back, then everything nice. So I don't need to get it back all the dimension, all the referencing, everything. It's very troublesome. Alright, so I can do it, make it done very easily. Okay, so next thing. Okay, when multi-body save the day. Okay, impossible fillets. This is actually always happens. When you want to create something like this, and you want to add fillets all around the edges. So when our fillet is large, maybe it will go to the adjacent edges. Then the adjacent edges will affect the fillets, and it will fail to create the fillets. So how multibody can help us in this case? Okay, remember you have this geometry. Let me add some fillets. Okay, let me add a 6 mm fillets to this edge. Okay, you will see it will fail. Okay, you cannot repair at all. Okay, you will fail. Let me show you the function. Okay, cannot. So in this case, how are we going to settle? Okay, let me examine this part. Okay, we have this, and then we just extrude one more this shape. Okay, when you facing this kind of impossible fillet, always think about multibody. Okay, because multibody do not have any adjacent edges which block us to create a successful fillet. For example, when I create the angle piece, when I extrude this, I don't check the merge result. So what is my result is, I will have two bodies, two separate bodies. Okay, so actually, if let's say I have two separate bodies, I can add the fillets full preview very easily without any restriction, because I do not have any adjacent sides to this one. This one and this one is two separated different body. It will not affect one another. Okay, so I can add very easy this one 6 mm. But what I'm going to do next, because right now already become two separate body, but my result is what I want is only one. Okay, so we'll use the function called combine. You can either use the combine here, okay, or you can right click over here, two bodies, combine. Alright, so we'll have three functions here, three options: add, subtract, and common. Add meaning these two will become together, join together, is a union. Subtract meaning minus. Okay, I can choose this one minus this one, or common meaning at intersection. Alright, in this case I will use the add and just hit OK. Then these two bodies join. Okay, I can continue to settle the remaining fillets. Nice. Okay, so always think about multi-bodies when you face this kind of impossible fillet, if possible. Okay. Next, local operations. Okay, I will directly show you in SolidWorks this part. Okay, look at this part. If I were to add a shell, okay, to the bottom face. Alright, example, I add a shell, maybe a 3 mm. Okay. So what we can see is the whole part. Okay, let me make some sections. Okay, as we can see from here, the whole part, it will become hollow. Okay, the whole part become hollow. This is because all the part is joining together, and when we apply shell, it will create the hollow to the whole joining solid body. So what if I only want to create the shell to the bottom face only, not to here, not to here, not to here? Okay, I can do it this way. I can using the help of multi-bodies. Okay, I separate it. When I create this vertical plate, I can don't merge this one, so I make it a different solid body. When this one rip under, I also make it don't merge. So you can see I have three separate body. Okay, so when I hide this one before I doing shell, you can see this one is a separate body. So if I add shell and select this face, it will affect only this body, not the adjacent bodies. So let me hide this one. Okay, let me hide this one. You see this one remains solid, but the problem is not joining. Okay, but like I shown you just now, very easy. We can select everything, so right click, combine using the add, done. So right now we achieve what we want. Okay, done. What we have, okay, Boolean operations. Okay, this is also another topics that we always use, another things that we always use when we want to create bodies. Okay, like this. We can always imagine this part actually is this one plus this one. Okay, when we look from the top, we see this shape. When we look from the side, we see this shape. So what if we draw this and we draw this, then we get this. Alright, I'll show you in SolidWorks. Okay, let me create a new part. Okay, let's say top. I will use this circle. Okay, let me connect it. Okay, let me trim. Alright, extrude. Okay, for example like this. This is what I look from the top. This is what I get. This one. Now I want to create this one. Okay, from the front view, and I will create the shape like this. Okay, for example, the tangent. Okay, I can offset it. Okay, let's say 10. Okay, and I just make it close. Okay, let me add some dimensions. 20. 20. Tangents. Tangents. Okay, for example. Again, I go to extract. Mid plane as well. Okay, make sure it is fully intersect, then don't merge. Okay, remember you need to clear the checkbox. So right now I have this one and I have this one. Okay, I can use again is the combine. Okay, I can utilize this combine function using common. The preview will become like this. Okay, so I get this shape. Again, show you the top is this shape, from the front is this shape. So these two combine at the intersection area, it becomes like this. Okay, so again, when you creating shape like this, you have two sides. When you look from the top is one shape, look from the side is one shape. You can always utilize combine functions, multi-body techniques. What else do we have? Okay, another example of using multi-body techniques. Okay, indent. Okay, indent actually is again another very powerful functions where I want to create the shape of this okay, to follow the red colors. You see this here. Okay, this shape must follow the red colors items. Okay, we can use indent. Okay, let me show you. Okay, I have one body. second body. Okay, then there's some fillets. Okay, in order for you to use indent, one thing you must remember is that these two body must be fully intersect. Okay, let's go, it must go through. Okay, so I go to insert, features, indent. Okay, this is my target body and this is my tools. Okay, you can see I get the shape very easy. So I can set even what is the thickness, or maybe I can set some clearance. Then I will have some clearance over here, but I don't want. Okay, let me hit OK. So let me hide this thing. This is the indent features that I just created. Very easy. Okay, so what if I want to create 3 indent features over here? Okay, there's many ways. Okay, but I will recommend that you're doing this way. We go back before the indent, show back this one. I'm using a circular pattern to pattern 3 of these tools. Alright, we go for circular patterns, select this one. Again, it's body to pattern. This one, 3. Okay, right now I have 3. So when I create my indent, create this one and this one. Okay, this one is this one and this one. Okay, let's see the result. Okay, but anyway, there's one thing I want to share with you guys is when we're doing indent, we must be careful whether we are selecting this side or this side. Okay, it will give you different result. Anyway, which side that we are selecting is depend on whether we want to keep or move. If we actually keep, if I using keep functions, I click this side, it will remain this side. It's the opposite way if I using remove function like this. So we have the controls, we have the full controls over here. Next thing is replace face. Okay, this one. Alright, I directly go into the SolidWorks, okay, to show you a better way. Replace face. Okay, this part is imported part. Okay, what I want to do here is I want to change the shape of this face. Okay, the curvature, everything is different, but since it is imported, okay, I cannot do any changes, okay, on the features. But because of my design intent, I need to change this face anyway. So one option that I can use is a replace face, but anyway this fillet is there. So before I going to change this, I need to remove all the fillets. Okay, so what I can do is I select all these faces using Control key. Okay, delete. Okay, delete face is a very powerful. It will remove all my fillets. See, right now I can do changes on this face freely. Anyway, it's imported. Alright, so I cannot change the curvatures. Alright, so I will going to insert another face, a surface body, come into this part so that we can do something on this face. Right, I'm going to insert features, imported. Okay, new surface. Okay, the surface is here. Okay, so I want to lift this, I want to move this up into somewhere in between here. Okay, again I repeat the function of move copy. I click this, drag this up. Okay, let's say it's 55, 60, 62.5. Okay, I'm going to replace this one to this one. Okay, meaning this height to this height, follow this shape, the new shape. Okay, I will use the surface functions. Okay, we call it replace face. I use the surface function here because actually surface body is a body. Surface body and a solid body is a multi-body. Okay, I always think surface as another kind of body. Okay, so surface and the new surface. So I just click OK. Oh, so you can see the face is replaced to this. Okay, maybe I move it a little bit. 63. Like this. Okay, so I already before I do the replace face, the shape is different, the curvature is different, and at the different heights. So once I use that replace face, you see right now they follow the face and all the curvatures like this. Of course, after that I can add it back all the fillets if I want. Done. So easy, huh? Alright. Intersect. Intersect is a very powerful function which first introduced in year 2013, this year. Okay, so it will actually recognize all the intersection and will find the intersection volume regardless bodies or plane or surface that you are selecting. Okay, let us see intersect in real actions. Okay, you see I have this part. In this part I have one extrude, one block, one cylinder, and one surface. So I want, okay, for example, I want to make it this way. Okay, I can do it using intersect functions. Okay, intersect. I straight away select three things. Okay, then I select intersect. So it will recognize all the intersections. Okay, before that I go back. First I make sure this thing do not merge together. Alright, so I have three separate body. Right, intersect 3. So you can see from here it will recognize all the region. And this one, and the small one. Okay, so I can select which one to keep, which one to discard. Okay, for example here, this one I want this one. In fact, this one don't need. This one want. Okay, so I get this. Okay, so actually it's up to us which one you want to select. Okay, I select this one. Sometimes we'll create some invalid components. Okay, let me analyze. You see, so it's a very powerful function. It will recognize how it intersects and just depend on how we select where we want, where we don't want. Okay, and we even have the option whether we want to merge result or merge or remain a multi-body. Okay, then it will remain about the different types of body. Okay, let me show you another example of intersect. this part, I have one surface and I have one solid. Okay, so let me do some section for you. Okay, from the sections you can see that this area, the solid is intersect, okay, overshoot the surface, but this area the surface is higher than the solid. Okay, what if I'm going to do an intersection here? Okay, select face, select solid, so I click intersect, so it will actually recognize this area, everything. Okay, so I can click, this is the one I want to remove. Okay, so only with one option, one functions, one features, I can create together, remove some volume and add some volume. You can do add and remove volume together. Okay, so this is a very powerful functions. Okay, next thing is about web. Okay, let me explain to you. If we want to create a web like this, you can see from here I have a pocket and I have a slot on cylindrical face. How to create this part? Okay, I believe some of you may know what is web options. Okay, anyway, I'm going to explain. Right. Okay, so for example, I have this cylinder. Right. So actually here I already make it two cylinders, exactly same size, exactly same locations. I'm using the copy. So for example, I only have one. Imagine that I only have one cylinders over here. Okay. When I want to do, okay, I have pre-defined a sketch, a pocket like this. So when I want to do a pocket cut on the cylindrical face, the function I'm going to use will be web. Okay, I just select the face and what is the depth that I want to cut, then I get this pocket. Okay, right now if let's say I want to make a slot, same thing, also web on this face. Okay, by right I should go and click here, seems everything okay, hit okay, but it's error because it's intersection. The face is intersect, so it will not let us to pass. Okay, so what if I insist I need to get this kind of features, this kind of shape? We can ask the help from Multibody. Okay, this is why I copy another one. Let me hide the first one. Okay, so I'm going to create the second slot web on this second cylinder. So meaning right now I have one cylinder with slot cut, one cylinder with pocket cut. Now it's the issue of combining these two. Select these two, again I'm using the function called combine. It's a common, I get this shape. So actually once you look the example that I show you, okay, sometimes you may find actually Multibody can help a lot, especially when those we call it impossible shape. Okay, we can always think about Multibody, how Multibody can help us. Yep. Okay, next thing I may talk a little bit about assembly. Okay, in fact this is a part. Okay, this is a part where I have two solid bodies. So this solid body looks like this. One, I will have a block and a cylindrical product, and another one is a cavity. Okay, it's a negative side of the first block. Okay, so I now create the core and cavity in part levels, but anyway I need this information in my assemblies. Okay, so how am I going to insert my multi-bodies features into assemblies? Okay, what I need to do is just right click here and save bodies. Okay, I want to save both, then I can create assembly if I want, for example. Okay, and okay, so the two bodies just now will save into two parts called part 3 and part 4. Let me see, let me open. Okay, it's not part 3, it's extrude 3 and extrude 2. So automatically SolidWorks will create the assembly and the parts. Okay, where is the part 2? This is the part. Okay, so the reference is remain there. Okay, meaning any changes to this part, any changes on size, shape, okay, it will reflect back to this part and so to the assemblies. This is how normally a mold maker, when they design their part, they split their core and cavity in the part levels, and then they save bodies. So these bodies, everything can be inserted into their full mold based assemblies, like what I did just now into these assemblies. Okay, I think that's all that I can show you on example of using multi-bodies. I really hope that these short webinars will give you some useful informations to inspire you on your way of designing your components in a more different way. Okay, when you face something very critical, where you cannot get the correct way to do, okay, you may think differently, think multi-body. Often you'll found that multi-body can help you solve a lot of problems. Okay, I have another example, just an ad hoc example, just a little bit to share with you. Okay, for example, you have a cylindrical like this. Okay, you have a hollow cylinder, make it thicker. Okay, you have a hollow cylinder and you have a lot of hole. Okay, you have a lot of hole on this sketch, on this face, cylindrical face. Let me make it up to next. Oh, it's a true hole. Then the problem is you don't know how many holes that you have. Okay, of course you can count one by one if you like. Okay, I will share with you a very quick tips how to count. Okay, you create another cylinder like this. Okay, then you extrude okay, using through all. Then make sure you don't merge the result. Okay, now I have two layers, two layers. So what I'm going to do is I'm going to using one thing called subtract. These two. Okay, subtract. I will use the second one. Use the second one, subtract this one. So I can, what is my final result? Is the whole, like this. Okay, you imagine that this part, okay, when I minus this part, the part that is not intersect is the whole area. So the whole area will become solid. The solid area will become no longer there. Okay, so I want to keep all the bodies. So what I'm going to do with all these bodies? Count one by one? No. How many solid body? I have 12 solid body, meaning I have 12 holes. Maybe you have another method to do lah, but this is one of the tips, one of the method you can consider. Okay. Alright, so I think that one really is the end of our webinars. Okay, so I really hope, again, I really hope I give you some very useful information that inspire you, give you some different way, different thinking of doing your design. Alright, thank you.